Leetcode problem 1036. Escape a large maze. So the problem is that there's a million by a million grid or xy plane, and the coordinates of each grid square are x and y. Yeah, so we use x and y as the coordinates. So let me make a drawing. So we're gonna start at the source, and we want to check if we can reach the target. And for each of the steps, we can move 4 directions, like southeast, west, and north. Yeah, we're gonna return true if we can reach from the source to the target. If we cannot, we're gonna return a false. So we just need to return true or false. So we don't need to check how many steps. Yeah, because a million times a million grid is a really large grid. Normally, we cannot pass. It's gonna be time limit exceeded if we were to calculate how many steps. So the problem is that we don't need to calculate how many steps. We just need to check if we can reach from the, for example, this is the target, and another one, this is and so this is the source, and this is target. Yeah, we just need to check if we can reach from source to target, and we're gonna return true or false. We don't need to return how many steps, because basically 10 to the power of 6 times 10 to the power of 6 is gonna be a really large number. 10 to the power of 12, normally it cannot pass. But it is easier because we just need to return a Boolean value, true or false. Yeah. So now the problem is that we are given this grid. We want to check two ways. One way is we're gonna check from the source to the target. So for example, here is a source. We need to check if I can reach from the source to target. Yeah, but there can be any kind of block. At maximum, there's gonna be 200 blocks. So this is a block subway. Maybe this way can be blocked. Yeah, so this means from the target cannot, from the source cannot reach to the target. Or maybe this target was blocked because there are 4 cells. Yeah, from the 4 directions, it is surrounded. Yeah, it means it cannot never reach the target. Yeah, so our problem is that we need to check 2 directions. First of all, we need to check if we can reach from the source to the target, and then we're gonna check from the target to the source if we can reach from the source to the target. But what if the distance is too far away? So for this example, the distance is too far away. Basically for BFS we cannot reach. Yeah, but we need to stop it early, and we just need to make sure it is valid. So the example is for example here. So for this cell, I'm gonna starting from this cell. This is my starting point. So I can move 4 directions, but if I move too far, I can move as long as I can reach, but I cannot reach to this direction, because if I reach to here, normally the surrounded areas cannot surround it enough if I goes too far away, because there are only 200 blocks. Yeah. So the problem is that how can I make the areas as big as enough? So for example, if I have 200 blocks, how can I block the areas as much as I can? So it's gonna be like this. Yeah. So only in this way, I'm gonna block the largest area. So for example, in this way, and for triangle, if this line equals to this line, normally I can make the largest area. So if this is a 200, and this is also 200, so yeah, normally because I only have 200 blocks, so it's gonna be 200. So for example here, this is 200, right? Yeah. So if this is a 200, we just need to check what is the length of this one. Yeah, because maximum we have 200 blocks, so we need to check what is the maximum. Yeah, so for here, basically we're gonna check like, so here is one block, here is two block, and maybe what is here. Yeah, so here we're gonna have like 100 blocks, I think. Yeah, we just need to calculate, because this is 200 and this is 100, this is 100, and this, for this one it is also 100. Yeah, basically here gonna be like 100, so it means 1 plus 2 plus I think plus 200. Yeah, because this is 200, so this line is also 200. Yeah, and this is also 200. Yeah, because this is 200, there are 200 blocks. So similarly here, we can still put 200 blocks. So this means 1 plus 2 plus, yeah, because here 1, 2, and this line, and similar as this line, it gonna have the same number of blocks. Yeah, because basically it's gonna be like this. Yeah, so it's gonna have the same number of blocks. Yeah, but it's gonna be plus to 199. Yeah, because if this is 200, basically this one we cannot count it. So from here it's gonna be 1. So from here it's gonna be 199. So in total it's gonna be yeah, n times n plus 1 divided by 2. So this n gonna be 199. Yeah, so the final result gonna be 199 times 200 divided by 2 times 100. So this gonna be the maximum areas in this area. Yeah, so we're gonna prepare a weighted set. If the length of the weighted set is more than this number, basically if it is more than this number, definitely those blocks cannot surround my, for example, if this is a source or if this is a target, definitely this block cannot surround it. Yeah, so if my weighted set is more than that, it means I go somewhere until I can go out of the boundary. If I can go out of the boundary, definitely, yeah, from this side, definitely I'm gonna return a true. Yeah, I'm gonna return a true. But I need to check both sides. For example, I also need to check from the source to the target. Yeah, similarly, I can check it like this. If the weighted set is more than that, this number, basically it means I can go out of the boundary. If from the start to the source, if I can go out of the boundary, and from the source to the start, if I can go out of the boundary, it means definitely I'm gonna return a true immediately. I don't need to wait until those 2 points meet together. I don't need to do that. I just need to check if I can go out of the boundary. If I can go out of the boundary from the start point to the source, or from the source to the start together, yeah, I mean from the start and from the source, if I can both go out of the boundary, definitely I'm gonna return a true. Yeah, and there are other cases. For example, we have a board, and there gonna be the source and target. Maybe there are only 4 squares surrounded with it. Definitely, it's gonna return a false immediately because it can never go out. Yeah, maybe here is surrounded by some blocks. Yeah, so definitely it can not go out. So I'm gonna return a false immediately. Yeah, I'm gonna return a false, and this is also a false. If either one out of them gonna get a false, definitely I'm gonna get a false. Yeah, so let's just start coding. So definitely we're gonna use a BFS. So inside I'm gonna use the start to the target. Yeah, I'm gonna use the start to the target to check. So I'm gonna give a pass at the moment, but the final return gonna be the BFS from the source to the target. If I can go from the source to the target and BFS from the target to the source, definitely I need 2 BFS. This is not a bidirectional BFS. We just use the 2 BFS to solve the problem. If I can go from the source to the target and I can go from the target to the source. Definitely, I'm gonna return true. Yeah. So this BFS is just gonna return a Boolean value. It can be true or false. Yeah. Now we're gonna design this BFS. I need some variables, so I need R and C. It's gonna be 10 to the power of 6. It's gonna be the boundary, 10 to the power of 6. And I need directions because I have 4 directions. So the 4 directions would be 0, 1, 1, 0, and minus 1, 0, and 0, minus 1. Definitely I have 4 directions. Let me check, do I need anything else? But let's just prepare the BFS, right? If we have a start, so this is our start. Start is the source, yeah. So we're gonna prepare a queue. Queue gonna be the queue, and inside it's gonna be a tuple of start. And I also need a weighted set. So the weighted set would be a set, and inside gonna be a tuple of start. Yeah. So the start is my weighted set, and also I put it inside the queue. Yeah. Now I can check the queue. So while queue, I'm gonna pop it out. So I'm gonna pop out coordinates. It is x and y. So x, y, and equal to q dot pop left. So this is just a tuple. Yeah, I pop out, for example, this is a source. It is 0, 0. I pop it out. Yeah. Now I would to check the 4 directions. So for dx and dy in directions. Yeah. Now I would to have a row and column. I just define it as x plus dx and y plus dy. If it is inside the boundary, so if 0 more than and equal to 0, less than r, and also for the column position, column is less than c is column. Yeah, and I'm gonna check this row and column not inside the weighted set. So this is basically BFS, and this is row and column, and this is row and column not inside the blocked set. If it is not inside, definitely my weighted set would add this row and column, and the queue would append this row and column. Yeah. Now as we used this block, so basically we're gonna need to turn this block into a set. So block would equal to, so this is the block. Yeah. Inside it's gonna be a set, and I'm gonna turn all of the coordinates to a tuple. So it's gonna be a tuple item. So for this item inside the block. Yes, inside of the block. Now I turn it into a set. So this means this gonna just be one time, because currently this block is a set. So this is okay. Yeah. And now I need to check if I can get a true or false. So if x, I'm gonna use this way. If x, y equal to yeah, I can also use a tuple. I think it's the same. If this tuple x, y equal to start, yeah, let me just use array. So if x and y coordinates equal to the target, if equal to target, I'm gonna return a true. Yeah, but I would to stop it earlier. So this means I need to check the set, or the length of the weighted set is more than my calculated value. So the calculated value is just a formula, n times n minus 1 divided by 2. So n gonna be the length of the blocked. Yeah, because currently this block is a set, but it is okay. So I'm gonna prepare a maximum value. It's gonna be n times n minus 1 and divided by 2. So this value is just this kind of a value. This is gonna be the maximum square, and we calculate it according to this formula. because only by this way we can get the maximum area. Yeah. Now we want to check if the length of the weighted set is more than the maximum value. I can stop it earlier. I can just return true. Or if I can find the target earlier, I can return true. If I cannot return a true, definitely finally I'm gonna return a false. So this means I cannot reach it. Yeah. So this is gonna be the entire code. Now we just need to check if it works or not. Yeah. So let me just run it to check. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it's pretty fast and it passed all the testing cases. And the difficult part is that we need to calculate the maximum square. Only in this way we can get the maximum square, and the formula is n times n minus 1 divided by 2, and this n is the length of the block. So if this is the length of the block, normally we're going to block it like this. And the area is calculated by, as I explained, it's going to be 1 plus 2 until plus 2 n minus 1. And this one, the final result is n times n minus 1 divided by 2. This means in these areas, there's going to be n times n minus 1 divided by 2 blocks. And the weighted set means we've already visited more than that. If we visited more than that, definitely we can go out of the boundary, because we're gonna never visit a blocked cell. We only visited the cell which is not blocked. It means we can go out of the boundary. If from this side we can go out of the boundary, from that side we can go out of the boundary. So we're gonna just return a true. True and true will be a true. So this is why we're gonna use a 2 BFS to check the final result. And now let's analyze a little bit about the time complexity. As here the weighted set is only like I think we're gonna consider this weighted set. This weighted set is only what is that? I forget. Let me check. Yeah, it is only like n times n minus 1 divided by 2. Yeah, so this gonna be the time complexity. Yeah, although we use the 2 BFS, but we can analyze it as 1 BFS. I think it is okay. Yeah, but the problem for the time complexity just becomes what is the length of the weighted set. Yeah, it means we can only visit so many numbers of the weighted set. So I think this is gonna be the final time complexity, I think. So this means if we visited more than this number, definitely we're gonna stop, because we can return true. Otherwise, maybe less than this number, we're gonna return false. We're gonna stop earlier. So this is gonna be the time complexity. And thank you for watching. See you next time.